This third video is on active transport, which is the opposite of passive transport. Instead of moving molecules from an area of high concentration to low concentration, this time it's moving against its concentration gradient, which is from an area of low concentration to high concentration, and it involves energy in the form of ATP. As shown over here, we have the most common type of active transport, also known as the Sodium-Potassium Pump. And this active transport pump is accomplished through a series of 6 steps. In the first step here, before I mention that, there in the outer region of the cell, there is a high concentration of sodium ions and potassium ions, which are in low concentration. And intracellular, we have a low concentration of sodium ions and a high concentration of potassium ions. So if it wants to move against this concentration gradient, sodium would have to move to the outside and potassium will have to move to the inside. So in the first step, in this shape of the pump, the sodium has binds to the transport protein, and then with the aid of ATP energy, phosphorylation occurs, which removes the third phosphate chain, the terminus, and it becomes ADP, adenine diphosphate. So now this helps the protein change shape here. So it's gonna go like, goes like this. So the and it could just get out of here. And now in this position, the transport protein will have a high affinity for the potassium ions. So it would bind, the potassium ions would bind to the sodium-potassium pump, and in this case it would release ADP, and this release of ADP energy changes the shape again, and this time after the alteration of the shape, the potassium can come to the intracellular region. And this process occurs over and over again as long as there is ATP energy.